In some instances, a box plot can tell us about the skewness of the data. About the skewness of the data. If the median is near to the center of the box, the distribution is approximately symmetric. So imagine, so median is here. Median is here. Q1, Q2, Q3. So almost these things are equal to each other. So what can we say? We can say that it's something like that. It is symmetric. So 50% here, 50% here. Okay? So it's a symmetric distribution. If the median falls to the left of the center, so this is the center, let's say, but median right now here, left of the center here. If the median falls to the left of the center of the box, the distribution is positively skewed. If Q2 is here, it is positively skewed. What is positively skewed means? How was it? It was something like that we said. Graph is positively skewed to the right. And if the median falls to the right of the center, which is center here, if the median is somewhere here, then it will be something like that, which is, it is negatively skewed. Simply, I want you to keep in your mind, if the median is near the center or at the center, we call this is symmetric, approximately symmetric distribution. If median is on the left, we call positive. If median is on the right, we call negative. Let's go now. If the lines are about the same length, the distribution is approximately symmetric. If the right line is larger than the left line, the distribution is positive. So right line larger than the left line. Distribution is positive. We will see example. If the left line is larger than the right line, distribution is negative. So, I mean, you may think like that. So, if you remember, this is negatively skewed, we said before. Now, let's go. Example. The data values are given, and we know how to find, so I'm not finding. So minimum is this, maximum is this, Q1 is this, Q3 is this, and median is this. So we have all the information by using this table. So now we are drawing. So when I look at here, can I zoom in this? Okay, anyway, so when I go now, so here now minimum, when I go now, here now maximum, this is now Q1, this is now Q2, median, this is now Q3. Now, let us read. The median falls to the right of the center. So, you know, for this rectangle, center will be somewhere here. So, our median is on the right side of the center. Therefore, we might assume that distribution is negatively skewed. So, if the median is right, it's negative. If median is on the left, it's positive. Or maybe it is better to keep in your mind this line, look at here, this line is larger than this one. The left line is larger than the right one. So it indicates that distribution is negatively skewed. Okay? So maybe this is better to keep in our mind. So like a number line, you may think if all the data less than zero means left, greater than zero, right? I'm just finding a way in my mind to memorize or to remember. Okay, you can find different ways also. But if this is bigger, that means this is negatively skewed. If this is bigger on the right side, which is positively skewed. But for the median, vice versa, we have, so if the median on the right, it is negatively skewed. If median is on the left of the center, it is positively skewed. Okay, I am pressing this. Now, second part. These are our data values. So from 1997, 1998, 2016 to 2017. So two different years, 97, 98 here, and 2016, 2017, it's here. Two different data values we have. Now, the 5-number summary can be used to construct a graph called a box plot. It's important that the box plot is scaled on a horizontal axis. Here is a horizontal axis that is scaled from 0 to 40. Why 0 to 40? Let's go back. So minimum is 90. Minimum is 19. The maximum is 31. Am I right? But this is not ordered. Is this ordered? This is not ordered, but when I check all the members, maximum is 37.
1 is the minimum.
Yeah, the minimum is, by the way, not 19. So 5 here, 3 is
The one
here.
on the right is
Where is 1? I couldn't see 1.
smallest is 3.21.
Yeah, 3.21. That's correct. 3.21 is the smallest, and the maximum one is 37.25.
The table on the right is ordered.
Now, this is the ordered one. I thought that these are the different values.
No, that's ordered.
Okay. I didn't read text. I thought that directly did different. So this is the ordered one. Very good. So minimum one is 3.21 and the maximum one is 37.21. So what is the logical thing to find, to choose the scale? So the scale should start from 0. Since after 0, I have 3. I have to show it. And the maximum could finish at 40. You can choose 50, 60, 70, 80, but no need, since the maximum value is 37. So if I divide them by 5 parts, okay, each of them 5 units length, so it's better to choose 40. So now let's see. It is important box plot scale on horizontal, so it's 0 to 40. This will be a convenient scale since our minimum value 3.21 and our maximum value 37.25. Now we are starting with the minimum value. Let's see, maximum value, where is it? Yeah, this is. Now in the previous slide, we put dot, but you can even put this one. It's same. I mean, you can do something like that. Okay. Or you can put like this, vertical, like a line segment. We can put, the meaning is same, even that, even this, there is no difference. So when I look at here, dear students, dear ladies, look at now, when I go now, I can say that roughly 3.21, roughly, I don't know, since this is the 5 units, it's clear that it's more than 2.5, so it should be 3, but not 4, so it's okay, there's no problem. I know I have algebraically, numerically calculated. And 37.25, yes, it's normal. 35 is here, 40 is here, it's okay. And then Q1 was 8.605. Since this is 5, since this is 10, and so it must be here, it's okay. And Q2, it's okay. Q3, everything is okay. Now, one question before going to other slide. This is positively skew or negatively skew? What
Positive.
positively. So I can understand this is larger than the left one. Or the median is on the left of the center. Center of this box, you may think it's here, so it's on the left. But I think better to compare the length of this line or tails. It's better for you. Now, let me go on. We can see that 50% of the data values appear to be clustered in the short span for the minimum value of the 3 to 1. So, since this is the median means 50% of the data. Q1 is 25% of the data. We know this. Now, we can likewise see that upper 25 of the data set appears to have a wide spread as the box plot shows by the length of the horizontal line that connects the third quartile and the maximum data value. So we know that this is Q3, okay? And we know that this is now Q2, right? This is median, by the way. What was the, sorry, Q1, Q2, yeah, Q3. So 75% of the data. And this is the, not Q3, of course. This is the maximum value, not Q3. Maximum value, minimum value. From the Q3 to the maximum value, we have a long span, so there are different data members here. Good. Let me clean and read one more time. We can likewise see that the upper 25% of the dataset appears to have a widespread as the box plot shows by the length of the horizontal line that connects the third quartile and the maximum data value. Okay, it's okay, there is no problem. Sometimes a dataset, chat screen, there is something, 1 minute. Yeah, you are right. L less than R. What do you mean L less than R? As a length, yes, as a length, if you mention, you are right. Sometimes a data set might contain what is called an outlier. Yes, it's very important. Yeah, my dear ladies, be careful. Be careful right now. What is the definition of outlier? An outlier is an extremely high or extremely low data value when we compare to the rest of the data values. One method for finding outliers in dataset utilize a measure called interquartile range, which is IQR, which is frequently abbreviated as IQR. Now, the interquartile range is the difference between the first and the third quartiles. Substituting these values, we find the interquartile range for this data, which is 8.65. This is now IQR, and we know how to calculate. Now, when we find the IQR, how can we determine which data is outlier? Which data values are in the outlier? Which data values could be not considered statistically since they are not giving accurate information to us? Let me again explain. All the data values are here, 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 okay, all of them. But there's something just here, or there's something just here. So when you talk about if these are the average salary of the people, think like that, average salary of the people. So when I talk about the average salary of this factory, let's say, or company, I should use only this data. Why? There is no correlation, this number with them or this number with them. So let's say this is taking $50, but they are taking, let's say, 500 till the 600, and one take $10,000. So if I use this, it's directly increase the average. If I use this, it's directly decrease the average. So, but if I omit this, ignore them, so I can use only this data. So the question is this: how can I formalize this ignoring, removing? How should I decide which data values are outlier, which data values are not outliers? So the formula is this. The first is the first quartile minus 1.5 times the interquartile range, and the second is the third quartile plus and half times. Forget about this text. Look at this one. Q1 minus 1.5 times IQR gives us the left side, left outliers, which is the very small numbers. Q3 plus 1.5 IQR gives us the extremely large. So Q1 minus 1.5 times IQR gives us the extremely less numbers, less amounts, quantities, and Q3 plus 1.5 IQR gives us the extremely high values. So we call these values are outliers. These two formulas provide us left and right endpoints of an interval. Data values that lie outside of the interval we will consider be outlier in dataset. So this is, let's say, our interval. These are acceptable. These are yes, let's say, we can accept, which is Q1 minus 1.5 times IQR. This is now Q3 plus 1.5 times IQR. But if you have any number here, no, we call these are outliers. These are outliers. These are the bias. Okay, these are not representing our data. Now, numerically, let's see then. Substituting in the formula, we can find the left and the right endpoint, which will be negative 4.31 and 30.13. Okay, so our interval is between negative 4.31 and 30.13. What does it mean? When we look at our data set, I will show you right now, the numbers less than this, if we have, actually we don't have, will be called outliers. The numbers which are greater than this number will call outliers, which we. So look at here now. How many minutes we have? We have, right?
5.
Not finished.
Yeah, 5 minutes.
Okay. So Arwa Sabah is our student. Arwa Sabah. Do you know?
No, she's not, I guess.
Okay, so let me say X. Now, since in the previous slide, we got the right end, okay, upper bound, 30.13. Look at now, there are two data members in our data set, which is 31 and 37. Now we will call that these are outliers. So when we talk about the average, we mustn't calculate this. These are our outliers. Why? Most of the data, 3, 4, 5, 6, 8, 9, 9, 9, 9, or 10, whatever, 11, 13, here 20, but after that directly jump to 31, after that 37. So there is no correlation, there is no direct relation with these data members here, all these data members with the last data members. So how we decide this? By using the formula. So Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. So we are calling these two things are outliers. So the meaning of outliers, we have to remove from the data set when we calculate the average, when we do, or when we want to make prediction for the future, we shouldn't consider these two numbers. Any question? The meaning of outliers and how to find it?
Sir, so the outliers are the values that we will not take.
We are
when
not
take
taking, yes.
average.
Let's say rubbish, okay? They are meaningless things, okay? But again, let me give you an example. Outliers, you are a class, but let's say there are 20 students. I did one mathematics exam and 19 students took minimum 70, maximum 100. I mean, the range of 19 students from 70 to 100. 70, 72, 75, 80, 85, 90, 92. But one of the students got 2, just 2.
So
now,
the
if I calculate,
2 outlier.
2 is outlier now. If I calculate the average of the class, I am reporting to the director, let's say. I am reporting to the government. The average of my classes, if I use that 2, directly will decrease. Since you know the average means adding all the numbers divided by how many. So when I add 2, directly it decreases my average. But if I omit 2, my average will be 75. With 2, my average will be, let's say, 60. I don't know, I have to calculate. But it will be, it's so clear that my average will be directly drop. And that is not showing my actual class average. And then what can I do? How can I use this outlier? If I am vice principal, academic coordinator, dean, or director, whatever, I wonder, this student got this mark, that means there is a problem here. What could it be problem? Maybe she was sick. Maybe she had psychological issues. Maybe she fight. Maybe, I don't know. I mean, there could be lots of things, but it is clear that there is a problem there. So what can I do? I can call that girl. I can talk with the teacher. I can send the counselor. So talk about the problem. What is the problem? Find that one. So if I want to do something, I can use this outlier. So this is total depending of my aim, my goal. So what I want, I want to find the problem. Yes, outlier is a very good thing. I can use this. But if I am talking about the average GPA of the school, average GPA of the class, So using this outlier, it's not fair. Since this is extraordinary case, it's not normal case. It doesn't represent my school, my class, my lesson. Am I clear?
Yes,
Or
thank you.
you are doing one graph. So, for example, from the beginning, till the last day of the school, one specific student got 10 different marks, 10 different marks, but one of them zero. All the others 9,500, 9,500 or 85. And so it's logically, as a teacher, I should think, what's going on? What is this zero? Okay? Am I clear?